This is basic demo of the SuperCopier desktop for NVMe SAS SATA mixed ports drive duplicator units. This product is very popular since it supports many digital storage media and cloning methods. It is a standalone drive duplicator, imagers, deploying and cloning unit with maximum flexibility to clone from any port to any port with mixed storage media, supporting all the major storage interfaces: SAS, SATA, NVMe, M2 NVMe, U2 NVMe, and PCIe, USB, IDE with adapters, M2 SATA with adapters. This video will review the unit's ports and application using Ubuntu OpenOS. The unit is built with extremely performing hardware with i7 11th generation CPU and 16 gigabyte of DDR4 memory. It includes 10-inch high-resolution monitor with touchscreen that it's mounted on a stand. The monitor is connected to the side of the unit with USB touch screen cables and DC power cable, and connected to the back of the unit with HDMI cable. Those are the cables in the back and the HDMI going to the back of the unit. The unit is built with 4 SAS SATA ports designed as a target port. The user can connect 2.5-inch, 3.5-inch, and any other shape of SAS SATA hard drive and SSDs to the SAS SATA extension cables. Those are the RAID cables. This is, for example, 2.5-inch SSD, SATA SSD. Also, the unit has a built 4 U2 NVMe ports, and it's supplied with 4 M2 to U2 adapters. That plug directly into the U2 ports. What is special about those M2 adapters is that they support 110 millimeters long of NVMe SSD and have an easy locking mechanism gadgets that allow the user to pop in and out the SSD without needing to screw in the SSD. This is an example of the white gadgets. In the end, you just press on it and the SSD pop out. Now, one of the U2 ports is designated as source port, and the other 3 U2 ports designated as a target port. A target port can be reassigned as a source port with a full writes protection to enable multiple simultaneous multi-imaging in multi-sessions runs. U2 NVMe ports are more generic than M2 NVMe, and the user can plug U2 NVMe SSDs, mostly used in servers. They look like 2.5-inch SSD with 68 pins, into the port by using the supplied U2 extension cables. So pretty much remove the adapter and plug the U2 directly to the cable, end of the cable. U2 ports can be used for U2, M2, and PCIe NVMe. One important remark about an open tray concept we are using here is that it has a few benefits compared to the server enclosures that many of our competitors use. With an open drive tray, so all the drives are open to the air. The ventilation and the cooling of the drive are much better if needed. The user also can even add external fan, especially for NVMe SSD that they are getting very hot. Also, the user is not restricted to use only drives with 2.5 and 3.5-inch size. For USB ports, there are many USB 3.2 ports in the front of the unit and in the back of the unit. Now, let's start with plugging M2 NVMe SSD in U2 source 1 ports, and we'll turn the unit on by turning the on-off switch in the back of the unit near the power supply and press on the silver push button on the side of the unit to boot the unit. So we plugged here U2 NVMe SSDs in port S1 U, then NVMe ports. And now we're going to turn the unit on. Now on the screen, we can see that coming up is the SuperCopier main application screen with all the icons, all those touchscreen icons. Let's talk for a moment about handling the U2 ports. Looking at U2 ports, we see that U2 LEDs are powered up, and the BIOS is trying to detect the drive attached to the U2 ports at boot time. Only for NVMe ports, the user must plug NVMe SSDs in the U2 ports at boot time, so the BIOS will recognize that port as NVMe. Before the user starts using the unit, he and she should plug 4 U2 NVMe SSD into the 4 U2 NVMe ports to initialize the ports. After initialization, the ports become hot swappable. This process connecting NVMe SSD at boot time is special for NVMe ports since they are pure PCIe storages. Also, if NVMe SSD contain bootable image like Windows, the BIOS will try to boot from the NVMe SSD instead of the unit internal storage. That depends on the unit's motherboard. If that happens, the user can access the BIOS of the unit at boot time and change the boot sequence to boot from the unit internal SSD. Now let's see how fast we can read data from NVMe SSDs. We'll tap on the erase menu and tap on the erase mode and select verify only from the drop menu. That will run on a drive to confirm that the drive is empty. But here we just want to demonstrate how fast the unit can read for NVMe SSDs. Now let's go to the drive detection script by tapping on the scan drive icon to detect all the drives that are attached to the unit. So we'll tap on that, and now we'll tap on scan drive. And this is the drive selection screen where all the drives that attach to the unit will show in this screen. Now what we can see here that the system detects one SSDs in source 1. This is the NVMe that we plug. And we also plug 2 SATA SSDs in port 4 and 5. You can see that the LED of 4 and 5 also are light on. And now we want to just select by tapping on the checkbox on the left of the model of the NVMe PCIe. It means we're going to select that to a run, and we tap on the yellow man to start running a session. So now we're running a session of erase verify on source 1, which is an NVMe, and you can observe immediately the speed is really amazing. We're running around close to 200 gigabytes a minute. So let's run for a few seconds and then we can abort that session and continue on. So I tap on that one and abort the session, and I'm sure, and I say yes. Now it will flag red. Session is aborted. Now let's run about session that we will run a cloning session from target 4 to target 5. Those are SATA to SATA imaging. So we'll have to go first to back to the copy screen, select a mirror copy, select at least one hash value, let's select SHA-1, and select hash target and compare this hash mechanism when you copy is very important for authentication of the image. Basically what it does, while we're running the image, it calculates a hash value on the entire drive, and the hash target and compare result after the cloning is done is running one more pass over the target, calculate the hash value of the target, and compare source to target to make sure that they are matching. Okay, so let's go continue to the drive detections. Now what we can see that the system detected the drive 4 and 5 as before. Now if you tap on a model number, you have more functionality to do on the drive level. You know, there's many other things that you can do for it. It depends what is the drive has, including HPO and DCO, smart test, short test, or long test. And if the drive is a BitLocker, you will have option also to open the BitLockers. Now, what else we can see that both of those drive 4 and 5 are marked as a target in the role. And in order to have a run of cloning, one of them need to be source. So we're going to change target 4 to be source. We change the role of target 4 to be source and target 5 to be target. And we're going to select both of them to run imaging sessions that we select already the setting for it. So now we're running a session of cloning from port 4 to port 5, SATA to SATA. Those are 250 gigabyte SSD, Samsung SSD. They should be very fast. And you can see the speed is extremely fast. I think that it will end around 31, 32 gigabyte a minute. That's pretty much where the limitation of SATA storage is. So let's abort that session. Now this screen, for example, has session history that you can see all the running sessions and the result of it. Also, we can go to more and see more information about the session that we run, the log, and where it saved the log file, and we can view the log from here. But let's go also to the more options that we have. On cloning, we have a few different mechanisms or ways to clone. Mirror copy is the one that we just used. Quick copy is just copying the partitions. Selective capture file in folders, and you can hash each file separately. Copy from VHD, if you have like a virtual drive, images on a one large drive, you can select one image to deploy to the target. Copy to a folder is pretty much copying all the files from source to one big folder in a tree on the target. Copy to image is creating a VHD file. And there is some more settings here that you can set for capture, like detecting BitLocker, changing the ports to be upload mode. That's mostly forensic, or one-to-one mode where it would be source target automatically. Can go to setting. Here you have many other settings that you can use, including log tools, log databases, Most important is upgrade software from USB. You plug a USB stick with the software update and you just click on it. That's the end of this video.